In this lesson, we are going to talk about implicit differentiation. Now, in most derivative problems that we've done already, we've been taking the derivative of x. So we have been respecting the variable in the problem. But sometimes the variable does not match the derivative that we're taking, and we represent it by dy over dx. And dy over dx means you're finding the derivative of y with respect to x. So here we have the variable dilemma. We need to find the derivative of 4y squared with respect to x. So to solve this, we treat y as a separate function and apply the chain rule. So we take 4, put the y squared in brackets, and if we take the derivative of this, we apply the power rule to 4y squared, which would become 8y times dy over dx. So the derivative of y with respect to x, because that's what's inside the variable. We're using the chain rule there. So to find dy over dx in an equation that cannot be solved for y, we must use implicit differentiation. And this is indicated by dy over dx, not y prime. So if you ever have an equation where you're taking the derivative and there are two variables like x and y, you must use dy over dx. So here we have our first example. X cubed plus y cubed equals 10. And we need to find dy over dx. So we differentiate both sides of the equation with respect to x. So you're good at taking the derivatives by now. So x cubed becomes 3x squared plus 3y squared times dy over dx equals 0, because the derivative of a constant equals 0. So remember, when we're differentiating the letter y, so y squared, we use the chain rule. And so what's inside of that y is the derivative of y with respect to x. That's why it becomes 3y squared times dy over dx. And that's simply how you write it. Now we're required to solve for dy over dx. So we isolate 3y squared times dy over dx. Move the 3x squared over to the right-hand side of the equal sign, so it becomes minus 3x squared. Isolate dy over dx, so I divide by 3y squared to both sides. Simplify by canceling the 3's. So dy over dx equals negative x squared over y squared. Here's our next example, using implicit differentiation to find dy over dx for the equation x squared plus y squared equals 4x times y. So you can see that this equation has the variable x and the variable y in the equation. So we have to use implicit differentiation. The end result will be dy over dx equaling something. So the first thing we need to do is to take the derivative of each term. And we know how to do that. So the derivative of x squared is 2x. The derivative of y squared is 2y dy over dx equals, and then the right-hand side of 4xy, we're using the product rule. So 4x times the derivative of the second part is dy over dx. And the derivative of 4x is just 4 times the second part, which is y. So we had to use the product rule here on the right-hand side. Now we're going to have the dy over dx terms over to the left-hand side because that's what I have to solve for. It's asking me to find what does dy over dx equal. So you're going to treat that as one unit, like it's one letter. So we have to have the dy over dx's on one side of the equal sign, and I'm going to move them over to the left-hand side. So 2y over dy over dx minus 4x dy over dx equals 4y minus 2x. Next, what I'm going to do is I'm going to factor out the dy over dx because I can see that they're common on the left-hand side of the equal sign. So if I factor out dy over dx, then I'm left with 2y minus 4x in brackets equals 4y minus 2x. The opposite of multiply there is divide, so I divide by 2y minus 4x, and I divide the whole expression by 2. So dy over dx equals 2y minus x divided by y minus 2x. Here's another example, using implicit differentiation to find dy over dx for this equation. So again, the first thing I need to do is take the derivative of all the terms. And the derivative of 2x to the fifth is 10x to the fourth plus, and again, I use the power product rule here, so 4x times the derivative of y, which is dy over dx, plus the derivative of the first term, which is 4x cubed times y, and the derivative of y to the fifth is 5y to the fourth power dy over dx equals 0, because the derivative of a constant is 0. Have the dy over dx terms together on the left-hand side, and 10x to the fourth and 4x cubed y, I'll move them to the right-hand side of the equal sign. Factor out dy over dx becomes x to the power of 4 plus 5y to the power of 4 equaling negative 10x to the fourth minus 4x cubed y, because I brought those two terms to the right-hand side of the equal sign. Divide, so I get dy over dx all by itself, and then I have my solution. Find the equation of the tangent line to the curve of the square root of 2x plus the square root of 3y equals 5 at the point 2/3. So I'm finding the equation of the tangent line. So the first thing that I'll need to do is I've expressed the equation, instead of with a radical, I've changed the square root to 1/2, so 2x all to the 1/2, 3y all to the 1/2, and I need to take the derivative of each term. So by using the power rule, the 1/2 will come in front. So 1/2 times 2x, and then I subtract 1 from the exponent, so the exponent is negative 1/2, times the derivative of what's inside. So the derivative of 2x is 2, because I do the chain rule there. 3y to the 1/2, the derivative of that, I use the power rule, so the 1/2 comes in front. 3y in brackets to the negative 1/2. And the derivative of what's inside is 3 times dy over dx, because I have to use implicit differentiation here still, because I have two variables. I have an x and a y. So anytime you're dealing with y, you're going to write it as dy over dx at the end. And the derivative of a constant is 0. Now I need to have dy over dx all by itself. So I'm going to simplify this a little bit. Okay, I change the negative 1/2 to a radical in the denominator. The 1/2 in the second term goes in the denominator, and the exponent negative 1/2 becomes a radical in the denominator. So square root 3y. One over the square root of 2x is taken to the right-hand side of the equation and becomes negative. So I have 3 over 2 square root 3y dy dx, and so I have to divide by that. And so if I'm dividing by a fraction, it's the same thing as multiplying by the reciprocal. So multiply by the reciprocal, and then I simplify. I get negative 2 square root 3y over 3 square root 2x. So I found the value of dy over dx. And now I have to use the point 2, 3. So it says the tangent line to the curve at the point 2, 3. So I have to substitute the values of 2, 3 in for the letters x and y. Okay, so if I sub in the values in for x and y, my slope becomes negative 1. Because remember, anytime I take the derivative, the equation of the tangent line, that's actually the slope when I'm taking the derivative. So my slope is negative 1. I'm at the point 2, 3, and now I have to form my equation using y minus y1 equals m bracket x minus x1, because that's my equation form. y1 is 3, x1 is 2, and my slope is negative 1. Write it in general form, and my solution is x plus y minus 5 equals 0. So I'm finished. I found the equation of the tangent line.